Hello. In this video, I will go over different types of limits. This is Calculus 1, limits at infinity. So in this video, I will go over the different types of limits involving infinity. So let's kind of review graphs involving infinity. So here you have this graph, and this looks like some kind of odd degree graph, and then you have this vertical asymptote. So they want to know what is the limit as x approaches a, positive a to the left. So this is not negative a, this is one-sided limit. What is the limit or the y value as x approaches a to the left? So here's a, it's either to the right or left. We said the left, so it's this area. So we said that the limit is the y value, so this shoots up to positive infinity. So that's why this is positive infinity. Okay, what about this one? So this is review. Here we have this graph. What is the limit as x approaches a to the positive right? So here's your graph. Here's a. Look at the right side of a. What is the y value? It shoots up to positive infinity. Okay, so we will get 3. Here's your graph. Here's a. Uh, what is the limit as a approaches to the left of this graph? So here's a. To the left, it shoots down to negative infinity. Okay, here's 5. What is the limit as x approaches a to the right of f of x? So here's a to the right, it shoots down to negative infinity. Okay, let's talk about limit at infinity and horizontal asymptotes. So, and behavior. So, yeah, this is now we're talking about different limits. So, now we're talking about what happens. You probably remember this from rational functions, because rational function has a horizontal asymptote. So, if you have a rational function, the limit is technically the horizontal asymptote, right? So let f of x be a function defined on the interval from a to infinity, then the limit as x approaches infinity of f of x equals limit means as x becomes sufficiently large, f gets arbitrarily close to L. So yeah, so all that means is if you have a rational function, the limit is your horizontal asymptote. So we might have to like review. Oh, can I go up? Might have to review the limits of how to find the limits of a horizontal asymptote. Wait, did I? I think I went a little bit up. Yeah, here we are. Okay, so let f of x be a function defined on the intervals from negative infinity to a. Then the limit as x approaches negative infinity of f of x equals L means as x becomes sufficiently large negative, f of x gets arbitrarily close to the limit. Right? So this, if you look at this graph, it never touches the limit, the horizontal asymptote. It gets really close, but never touches it. The line at y equals L is the horizontal asymptote of the curve, and if y equals f of x, if the limit as x approaches negative infinity of f of x equals L, or the limit as x approaches infinity of f of x equals O. So just like I said before, basically if you have a rational function, the limit is your horizontal asymptote. Fact. If n is greater than zero, if n is greater 0 is a rational number, then the limit as x approaches positive to negative infinity of 1 over x raised to the n equals 0. Since any number divided by a very large number is gets really close to 0. So let's do an example. Here we have this graph. Let's see if I can make this. Yeah. Yeah, we have this graph, and let's answer some questions. I want to see if I can make this. One second. Let's make this to 40. Yeah. Okay. Okay, so find the infinite limit. Find the infinite limit and limits at infinity using this graph. Okay. So part A says, what is the limit as x approaches -5 to the left? So here's -5, and we're focusing on the left, so this side. And as you can see, the y value shoots up to positive infinity. So yeah, that would be positive infinity. What about B? What is the limit as x approaches -5 to the right? So here's -5. Now we focus on the right, so the y value shoots down to negative infinity. Okay, see, what is the limit as x approaches -5? This is related to one-sided limit. So remember, if these values are different, that means it doesn't exist, right? The limit uh, as x approaches 5 to the left must equal to the limit as x approaches 5 to the right of f of x. So if they're different, that means it does not exist. So you could put D and E. Okay. What about letter D? What is the limit as x approaches 0? Yeah, it looks like if you look at our graph, what is the limit or what is the y value as x approaches 0? And it doesn't say to the right or left. It looks like it would be negative infinity because here's 0, something closer to those close to the right. Like something larger than 0 would be like 0.1, and that y value shoots up down to negative infinity. Wait. So, no. Let me rephrase that. You have to figure out what the limit as x approaches 0 to the left and uh, what is the limit as x approaches 0 to the right, right? This would be negative infinity. The reason why, because the limit as x approaches 0 to the right is negative infinity, and then the limit as x approaches 0 to the left of f of x is also negative infinity. So that means that the limit as x approaches 0 must be negative infinity. What about uh, what about the limit as x approaches 3? So what you have to do is do the one-sided limit. So what is the limit as x approaches 3 to the right? What is that going to be? So here's 3 to the right. It shoots up to positive infinity. And then what is the limit as x approaches 3 to the left? there's 3 to the left, it shoots up to positive infinity. Thus, that concludes that the limit, since these are the same, the limit as x approaches 3 is positive infinity. Okay. What about f? What is the limit as x approaches negative infinity? So what is the limit as x approaches negative infinity? So if you look at your graph and look at the x value, here's -5. Anything smaller than that, -6, -7, um, it's like this invisible horizontal. It doesn't show you, but it doesn't go below above 1. It gets really close to 1, basically. So the limit as x approaches negative infinity would be +1 because it's like an invisible horizontal asymptote. What about g? What is the limit as x approaches positive infinity of f of x? So let's go back to your graph. Here's f of x. So anything larger than 3, so 3, 4, 5. As you can see, as the x value increases, the y value gets really close to -2. So it's going to be -2. Let's move on. Let's review asymptotic function. So basically the rules for horizontal asymptotes. So if you recall, if the bottom degree if the bottom degree is bigger, it dominates the numerator. If the bottom degree and the top degrees are equal, they work together. So what does that mean? Number rule 1, if the bottom degree is bigger than the numerator, your limit or your horizontal asymptote is y equals 0, right? For example, let's say you had y equals 3x to the 1 over 4x cubed. See how this degree is bigger than the top. That means your horizontal asymptote or your limit would be 0. Rule 2, if the bottom degree and the top degrees are equal, they work together, meaning you use a coefficient. So for example, if you had y equals 3x squared over 2x squared, see how the degrees are the same? You just use the coefficient, so the limit or the horizontal asymptote will be 3/2. Rule 3, if the top degree is bigger, it dominates the denominator. So if it's top heavy, um, yeah, you must use uh, it will be oblique and you have to do long division. So you have to do, if the degree on the top is bigger than the bottom, you have to do, it's oblique and you must use long division. So rules for limits at infinity. So you have this horizontal and oblique asymptote. So if the degree denominator is larger than the degree on the numerator, then the horizontal asymptote is 0. We talked about that. Um, the degree on the denominator equals to the degree on the numerator. The horizontal is the coefficient. And rule 3, if the degree in the denominator is less than the degree on the numerator, then the horizontal is oblique and you must use long division. So this is those this is a calculus course, so you can't in your calculus course you can't just say the limit is 3 because of the horizontal asymptote, right? You gotta show work. So this is a good way to like prove it, but let's do an example too. So let's say you have the limit as you have this rational function. And what is the limit as x approaches positive infinity of the rational function 3x minus 1 over x squared minus 5? So what do you think? So first we got to figure out, let's just figure out what the limit is without any algebra using your horizontal rules. So look at the numerator. What is the highest term on the numerator? 3x or 3x to the 1. Then do the bottom. Look at the denominator. What is the highest term on the denominator? It's x squared. Now, from the three rules, what would you consider this? Top heavy, bottom heavy, same, etc. This is bottom heavy, right? It is bottom heavy. That concludes that our horizontal asymptote is at 0 or the limit equals to 0. Okay, so that's a way to check it, but we got to do some algebra. So what you're going to do is you're going to divide. If you look at the denominator, what is the highest term on the denominator? X squared. So what you're going to do is you're going to rewrite this problem and you're going to divide each term by x squared. So you can say the limit as x approaches infinity, and then you're going to divide each term by x squared. So it's going to be 3x over x squared minus 1 over x squared, x squared over x squared minus 5 over x squared. Okay, so let's simplify it. What's 3x over x squared? That's x to the negative 1, so that would be 3 over x minus 1 over x squared is 1 over x squared. We here x squared over x squared is 1 minus 5 over x squared is, you can't really simplify it. So what you're going to do is rewrite this problem. The limit as x approaches infinity. And you're going to use this instead of that. So it's going to be 3 over x minus 1 over x squared. Okay. Then what you're going to do is just wherever you see an x, plug in infinity. So this would be 3 over infinity minus 1 over infinity squared, which is really infinity. And then you have 1 minus 5 over infinity. Okay, and then what is 3 over a very large number? We said that a number over a very large number gets very close to 0. Minus 1 over infinity, 1 over a very large number is also 0. This is 1 minus 5 over infinity, or 5 over a very large number is 0. So 0 minus 0 is 0. 1 minus 0 is 1. This is okay to have the 0 on the top because that would be 0, which is a real number. If it was on the bottom, you have undefined, and so you have to use another technique. So this is good. So the limit is 0. Just move on. Let's do example 3. So what is the limit as x approaches positive infinity of 3x squared minus 1 over x squared minus 5? So yeah, you can check it. So on your numerator was your highest term, 3x squared. On your bottom, the highest term is x squared. What can you say about their degree? They are the same. So when it's the same, just use the coefficient, which is 3 over 1, right? This has a invisible 1. So your limit is going to be 3. Now, we got to do some algebra. So what you're going to do is look at the denominator. The highest term is x squared, so you're going to divide each term by x squared. So you're going to rewrite this as the limit as x approaches infinity. and then divide each term by x squared. So this is going to be 3x squared over x squared minus over x squared. What's 3x squared over x squared? That's just 3 minus 1 over x squared. And then x squared over x squared is 1 minus 5 over x squared is just 5 over x squared. Then go ahead and put your infinity. So this is going to be 3 minus 1 over infinity, 1 minus 5 over infinity. So 3 is just 3 minus 1 over infinity, or 1 over a very large number is 0. And then you have 1 minus 5 over infinity, or 5 over a very large number is 0. So 3 minus 0 is 3. 1 minus 0 is 1. That's your answer. Okay, let's move on to example 11. So example 4 says, what is the limit as x approaches positive infinity? Um, so let's look at this. So what's the highest term on the numerator? It's 3x squared. What's the highest term on the bottom? It's x1. So is this top heavy, bottom heavy, or the same? It is top heavy. So you must use, it's gonna, yeah, it's gonna be, what is it? What is this going to be? So we said it's top heavy, it's oblique, and you have to do long division. Um, let's see. So what we'll do is we can divide each term. We'll divide each term by x squared because that's the highest term, right? So we'll say limit as x approaches. So over here we have 3x squared over x squared. That's going to be 3 minus 1 over x squared. And then x over x squared, that's negative 1x, so that's 1 over x minus 5 over x squared. Okay, so then you plug in your infinities for x's. So it's 3 minus 1 over infinity, 1 over infinity, minus 5 over infinity. So this is 3 minus 1 over infinity is 0. 1 over infinity is 0 minus 5 over a very large number, or 5 over infinity is 0. So you get 3 over 0, and you kind of have a problem. 0 is a bad thing on the denominator, so that makes it undefined. So it would be DNE. And yeah, so you could apply L'Hopital's rule, but yeah, for right now it does not exist. Okay, let's move on to example 5. What is the limit as x approaches infinity of 4x squared minus 3x plus 6 over 5x squared plus 1 minus 2x cubed? So, what is the highest term on the numerator? The highest term on the numerator is 4x squared. The highest term on the denominator is negative 2x cubed. So be careful, it's not in order on the bottom. So is this top heavy, bottom heavy, or the degrees are the same? It is bottom heavy. So your horizontal asymptote is at y equals 0. Let's do some work because we can't just say um, the limit is 0 because of the horizontal. It's bottom heavy. So you got to show the work. What we'll do is divide each term by x cubed because that is the highest. Yeah, that's the highest term, the highest power. So it's going to be 4x squared or x cubed. Okay, let's clean this up. Okay, 4x squared over x cubed, what's that subtraction, right? 2 minus 3 is -1, so that's 4 over x. Minus 3x over x cubed, this is a power of 1, so 1 minus 3 is -2. So that's minus 3 over x squared. This stays the same, 6 over x cubed. Over here, x2 over x cubed is what's 2 minus 3, -1. So that's 5 over x plus 1 over x cubed minus 2x cubed over x cubed. The x cubes cancel, so you're left with -2. Now go ahead and plug in x for infinity. So RBC and x plug in infinity. So it's going to be 4 over infinity. Okay, so 4 over infinity is 0. -3 over infinity is -0. Plus 6 over infinity is 0. 5 over infinity is 0. Plus 1 over infinity is 0. And then -2. So on the top you have 0. And then on the bottom it's -2. What's 0 over -2? Yes, that's 0. And it's okay. As 0, if the 0 is on top, that's fine. If it's 0 on the bottom, it's undefined. Let's do example 6. So what is the limit as x approaches negative infinity? So it's okay to have a negative infinity or a positive infinity. It's still a rational function. So your limit is technically the rules for your the limit is your horizontal asymptote, and you just gotta know the rules. So let's figure out what it is. So on the numerator, the highest term is 4x squared. On the bottom, it's the highest term is, or the highest power is -2x squared. It looks like the degrees are the same, so you just use the coefficient. So 4 over -2, which is -2. Your horizontal asymptote is at y equals -2. or that is your limit. So limit is also -2. Okay, now let's do the work. So we're going to divide everything by x squared because that's our highest power. So 6 over x squared. Okay, so let's clean this up. Uh, 6 over x squared is just 6 over x squared minus 3x over x squared. That's 1 minus 2 is -1, so that's -3 over x. 4x squared plus x 4x squared over x squared is just 4. And then this is 1 over x squared plus 5x over x squared, 1 subtract divided 1 minus 2 is -1, so that's 5 over x. -2x squared over x squared is -2. Whoops, one. Okay, so then just plug in for x, plug in infinity. So 6 over infinity minus 3 over infinity plus 4. 1 over infinity plus 5 over infinity minus 2. 6 over infinity is 0. Minus 3 over infinity is 0 plus 4. 1 over infinity is 0 plus 5 over infinity is 0 minus 2. 4 over -2, which is -2. Yeah. So on to example 7. Let's move on to example 7. So example 7 was the limit as n approaches infinity of 9n cubed plus 4n over n squared plus 2n cubed minus 5. So numerator highest term is 9n cubed. Denominator, the highest term is 2n cubed. What you can tell about these powers, they are the same. So that means your coefficient is, your limit is your coefficient. So your limit is going to be 9/2. Okay. I think you have the idea how to do the work. So the work, you basically divide each term by the highest term or the highest power, and then you plug in n for infinity. So I'm going to skip that step and just move on. Let's move on to example 8a. So what is the limit as x approaches infinity of 4x cubed minus 3x plus 6 over 5 plus x minus 2x squared? So what is the highest term on the numerator? It is 4x cubed. What is the highest term on the bottom? It is -2x cubed, -2x squared. And what can you conclude about the power? It's top heavy. So it's going to be oblique. And what happens when you have oblique? You're going to have to use long division. So step one, find oblique asymptote. Okay, so the numerator goes inside the box, the denominator goes outside. And what I want to do is make sure everything's in order. If you're missing a power, just replace it with 0. So on the numerator, we have 4x cubed minus 3x plus 6. It looks like we're missing the power 2. Yeah, we're missing the power 2. So it's going to be 4x cubed minus 0x squared minus 3x plus 6. And then you do the same thing on the bottom, but make sure it's in order. And it looks like we're not missing any power. So it's going to be negative 2x squared plus x plus 5. Okay, what to do next? So we'll try to get rid of this 4x cubed. So we're going to need, I believe we're going to multiply by negative 2. I'm going to put that negative 2 above the negative 3x. And we need an extra x because we have an x squared. So I'm going to put an x. Negative 2x times negative 2x times negative 2x squared is positive 4x cubed. Negative 2x, you got to do for everything. Negative 2x times x is negative 2x squared. Negative 2x times 5 is negative 10x. Distribute a minus. So this cancels. One over here, you distribute that minus, that becomes a positive. That's positive 2x squared. Distribute this minus, this is going to be positive. What's 10x plus negative 3x is 7x. And then bring down the plus 6. Okay. And then let's see here. Now I got to get rid of this 2x squared. I think I'm just going to multiply everything by negative 1 because I don't need any more x's. So negative 1 times negative 2x squared is positive 2x squared. Negative 1 times x is negative x. Negative 1 times 5 is negative 5. And then distribute this minus. So this cancels. This becomes a positive. 7x plus 1x, 8x. And then distribute this minus. This becomes positive. 6 plus 5 is 11. So this is your remainder. What we have is this linear line, right? So you tell me, what is the limit at, so if you recall, this is a linear line with a negative slope and a b of negative 2. So if you want to draw that, it's fine. It could look something like this. Here's negative 1. It has a negative slope of negative 2. So you tell me, what is the limit? What is the limit as x approaches positive infinity of the linear function negative 2x minus 1? So as x goes to positive infinity, the y value shoots down to negative infinity. Okay, so that's your answer. Let's move on to 8. Oh, 8b. So it's the same problem. Whoops. Sorry. So Yeah, 8b state is the same problem. They only ask for the limit as x approaches negative infinity. So we figured out it is an oblique. It's y equals negative 2x minus 1. That would look something like this. So what is, as x approaches negative infinity, what happens to the y value? It shoots up to positive infinity. You could also have, you could have also done this. You could have, so you could say limit as x approaches negative infinity, and then you just replace x with negative infinity. So that would be negative 2 times negative infinity minus 1. Negative 2 times negative infinity is 2 times infinity minus 1. What's a very large number minus 1? It's still infinity. That's, yeah, you could have just plugged it in and it would have worked. Okay, let's move on to example 9. What is the limit as t approaches negative infinity? Okay, so on the numerator, the highest term is 7t squared. On the bottom, oh no, it's in factor form. So what you're going to do is kind of FOIL it out, or maybe FOIL out not everything, maybe just a few things until you get the highest power. So 1 times 3t, 1 times 3t is 3t, 1 times negative 2 is negative 2, t times 3t is 3t squared, t times negative 2 is negative 2t. So what's the highest term? It's 3t squared. And what can you say about these two powers? They are the same. So your limit is 7/3. Okay, let's move on to example 10 with involving square root. Okay, number 10 says, what is the limit as a approaches positive infinity of the square root 5a squared minus 1 all over a plus 10a squared? So you can rewrite this. This is all over square root, so you can write it into two square roots. So you can say square root of 5a squared minus 1 over square root of a plus 10a squared. And then kind of simplify this. If you take the square root, yeah, if you take this square root of 5a squared, that would be square root of 5a. And I don't even care about the negative one because it's not the highest term. Now do the bottom. Square root of 8, I don't really care about that one because that won't give me the highest power. It's this one we care about. What's the square root of 10a squared? Well, square root of 10 is square root of 10. What's the square root of a squared? It is a. So these are the highest power, and then they're the same, so it's just the coefficient. So it's going to be radical 5 over radical 10. And then what you want to do is radical 5 over radical 10 is the same thing as square root 5 over 10. And what you could do is reduce the 5/10. So that would be square root uh, reduced by 5. So this is 1 over 10 divided by 5 is 2. And what is square root of 1/2? So that's the same thing as square root of 1 over square root of 2. And then the square root of 1 is 1. And then on the bottom, square root of 2 is just square root of 2. You can take this one step further. You can rationalize the denominator by multiplying top and bottom by radical 2. So 1 times radical 2 is radical 2, and then radical 2 times radical 2 is 2. limit. About 11. What is the limit as x approaches infinity of the square root of 5x squared minus 9 all over x minus 1? So uh, let's fix the numerator. We only care about this 5x squared. I don't care about this negative 9 because it's not going to give me the highest power, right? So what is the square root of 5x squared? Well, the square root of 5 is just square root of 5. The square root of x squared is just x. Now do the bottom. What's the highest term on the bottom? It's x. And what can you say about these powers? They are practically the same. So when they are the same, you use the coefficient, which is radical 5. Okay, number 12, what is the limit as b approaches negative infinity of square root of b squared plus 3b all over 1 plus 8b? So on the numerator, I only care about this b squared because that'll give me the highest term. So what is the square root of b squared? Is b. On the bottom, what's the highest term on the bottom? It's 8b. And what can you say about the power? They are practically the same. So you use the coefficient, so it's 1/8. Okay, number 13. What is the limit as n approaches infinity of 4n over the fourth root of 4n fourth minus 1? So on the numerator, the highest term is 4n, or 4n to the 1. On the bottom, well, you got to be careful. I think I only care about the 16 and fourth. I don't care about the negative 1. But how can I rewrite the fourth root of anything? That's the same thing as power to the 1/4. So you can rewrite 16n to the fourth raised to the 1/4. So you raise everything to the 1/4. So 16 to the 1/4 is 16 to the 1/4. And so when you raise, you multiply. So 4 times 1/4 is 1. So what can you say about the coefficient, the power? So they both have a power of n. So it's only the coefficient we care about. So it's going to be 4 over 16 raised to the 1/4. And what is 16 raised to the 1/4? I believe it's 2. So 4 divided by 2 is 2. Let's move on to 14a. Okay, 14a says, what is the limit as x approaches a positive infinity of 2 raised to the negative x? So all you got to do is replace your x with infinity. Let's see. Or you can rewrite this. You could rewrite this as a positive power. That's 1 over 2 to the x. So what is the limit as x approaches infinity of 1 over 2 to the x? Replace your x with infinity. So what's 1 over 2 to infinity? 1 stays the same. 2 raised to infinity is just infinity. What's 1 over infinity is 0. One note is that this is not a polynomial, so you can't use the degree. Okay. What about b? What is the limit as x approaches negative infinity? So we can still use this equation, 1 over 2x. So that's 1 over 2, and then replace x with negative infinity. 2 raised to the negative infinity is negative infinity. And what's 1 over negative infinity? It's still 0. Wait. No, the correct answer should be infinity. So what I'm going to do is I'll put it back to your original equation, 2 to the negative x. So you can say, let me rewrite, limit as x approaches negative infinity of 2 to the negative x, and then replace x with negative infinity. So it's 2 minus negative infinity. 2 negatives becomes a positive infinity. 2 raised to infinity is just infinity. The correct answer is infinity, not 0. Okay, let's move on to 15. 15a says, what is the limit as x approaches positive infinity of x7 minus 1 over x4 plus 1? So this is a rational function, so what's your highest term on your numerator? It is x7. Now do the bottom, what's the highest term on the bottom? It's x4. So what can you say about the powers? They are top heavy. And that would be oblique. So you would have to do long division. So go ahead and try set that up. The denominator goes outside, so it's going to be x4 plus 1. The numerator goes inside the box. We are missing several powers. We're missing power 6, 5, 4, 3, 2. Right? So what we're going to do is replace those powers with 0. So it's x7 plus 0x6 plus 0x5, 0x4. Okay, so let's get rid of the x7. So I got to multiply it by x cubed. And I'm going to put it above the 0x cubed. So x cubed times x4 is x7. And then x cubed times 1 is x cubed. And distribute a minus. So that would be, this cancels. So now you're just left with negative x cubed plus 0x squared, 0x plus 1. Yeah, this is your remainder. So your equation is y equals x cubed. Your oblique asymptote is y equals x cubed. So it's going to be the limit as x approaches positive infinity of x cubed. So now you may plug in x for infinity. So this would be infinity cubed, which is infinity. So your final answer is infinity. Okay, let's move on to B. Same problem. The only difference is it's negative infinity. So we said that the limit, your oblique asymptote is x cubed. So it's going to be the limit as x approaches negative infinity of x cubed. So you replace x with negative infinity, so it's going to be negative infinity cubed. And then what's negative infinity raised to the third power is negative infinity. Okay, let's move on to 16. Okay, 16, we have what is the limit as x approaches infinity of 7x squared minus x plus 1. And then on the bottom, it's 5x, parentheses 5x plus 3 squared plus parentheses 3x minus 1 squared. So The numerator of the highest term is 7x squared. The bottom, you gotta, unfortunately, you gotta FOIL it out, but you don't have to FOIL out everything. I'm going to FOIL out this 5x. So what's 5x squared? It is 25x squared. Now I'm not going to FOIL out the 3 because that's not going to give me the highest power. So what about here? What's 3x minus 1 squared? Well, if you square 3x, that's going to be 9x squared. And I don't care about going further because that won't give me the highest power. You could combine the 25x squared and the 9x squared, which is 34x squared. So what can you say about the powers? They are both to the power 2, and it's just a coefficient, so it's 7 over 34. So yeah, your limit is going to be 7 over 34. Let's do one more and then we'll call it a day. So 17 says, what is the limit as x approaches infinity of 5x plus 1 over this mess? Square root of x squared plus 1 plus square root of x squared minus 3. So on the numerator, the highest term is still 5x. Bottom, I'm going to just take the square root of x squared. I don't care about the 1 because that's not going to give me a high power. So what is the square root of x squared? It is x. Plus, what is the square root of x squared over here? That's also x. I don't care about the negative 3. So if you clean this up, this is 5x, and then 1x plus 1x is 2x. And what can you say about the power? They are the same, so we use the coefficient, which is 5 halves. So your limit is 5 halves. Okay, I am going to stop here.